Hmm. Welcome, friends. The next topic is the physical physical significance of the dimensionless parameters. In fluid mechanics, you have studied the dimensionless analysis, which are related to the functions formula derivation. Okay, for example, Radalis method, Buckingham by theorem are used to relate the main function to the related functions. Okay, very important topic in the fluid mechanics subject. Here also we have some dimensionless numbers which are related to convection heat transfer. Okay, then let me discuss one by one. Okay, first one is Reynolds number. Reynolds number. Reynolds number. Reynolds number means the ratio of inertia force to viscous force. What is meant by inertia force and what is meant by viscous force? This is very different main definition. The inertia force means the fluid having certain mass, because in the world every matter having certain mass. For example, consider 1 liter water having 1000 grams of mass, but 1 liter of oil is not having a 1000 kg of mass because of density. Okay, you already know. Okay, then 1 kg of sand, which is volume occupied by 1 kg of sand is not equal to volume occupied by 1 kg of sponges. Okay, therefore every substance having certain amount of mass. Okay, for inertia force means if consider a steel ball, the first event is I can throw the steel ball from uh, throw the steel ball to a particular distance. For example 5 meters. How much effort to give the to throw the steel ball from me to the particular distance? Then the second event, consider a plastic ball and the distance to throw is same as 5 meters. Then how much effort to give to throw the plastic ball to a particular distance? The amount of energy needed for the steel ball is more when compared to plastic ball. Is everybody knows. Okay, then what based on this energy consumed? It is based on the amount of mass and amount of speed, amount of mass of the object and amount of speed of the object. How much the weight of the object and how the speed of the object. This is the main parameters to main parameters of the power requirement of the particular object. Okay, then only based on the or according to the concept, the steel ball having consuming more effort and plastic ball consuming less effort. Okay, in that two parameters, one is mass, another one is velocity. Okay, then based on the mass certain force create for particular amount of mass we give certain amount of force. Okay, this force is called inertia force. In another situation, consider a plastic ball and consider a same steel ball. Once I throw a particular ball, if the impact of plastic ball is not affect the ball, but the impact of steel ball create a major fracture or major failure or major damage in that ball. Okay, because of this mass alone. Yes, the speed of the steel ball as well as plastic ball is same, but the steel balls plastic ball doesn't affect any uh, problem in that vertical wall, but the steel ball create a great impact in that wall. Then how the difference is there? The main difference is the mass of the object. Okay, therefore the force created by the mass of the object is called inertia force. This force is based on the amount or density of the object. Okay, then viscous force means the fluid property. What is viscosity? Viscosity means the resistance to fluid flow. Therefore, viscous flow is the inertia force is the flow force based on the amount of mass. The viscous force is the shear force is reduce the flow or retard the flow. Okay, viscous force the force which is used to or which creates the velocity reduction. Okay, because the viscosity property is reduce the fluid flow. Therefore, viscous force is reduce the fluid flow. Therefore, if a particular fluid is having lower viscosity means the Reynolds number is higher for a same condition. For same condition, same situation, but the fluid is lower viscosity and another one fluid is higher viscosity. Therefore, the Reynolds number for lower viscosity fluid is higher and the Reynolds number for higher viscosity fluid is lower. Therefore, for same situation, one difference is the two different fluids. It's a difference. Okay, therefore, based on the viscosity of the fluid, the Reynolds number varies. Okay, therefore, therefore it cannot possible to maintain the Reynolds number as constant for two different fluids. Okay, for same situation. Okay, this is very very important point. In that book, on all books they are giving a definition of Reynolds number only, but what is inertia force and what is viscous force is not available. Okay, then only I can explain the what is inertia force and what is viscous force. Okay, but inertia force, viscous force is explained in different subject and different in already they explained in the engineering mechanics subject. Okay, so that they are not explaining here, but small memory remembering I can now I explain the inertia force and viscous force. Okay, mass number is equal to inertia force by viscous force. It the characteristic type of flow, whether it laminar or turbulent. Okay, the mass number is a dimensionless quantity. It characteristics the type of flow, whether it is laminar or turbulent. Then second, Prandtl number. Prandtl number. Prandtl number is relation between Prandtl number is a relation between the momentum diffusivity and thermal diffusivity. Momentum thermal momentum diffusivity means the mixture or diffusion based on the fluid mechanics, it is velocity, and thermal diffusivity is based on the thermal heat temperature. Okay, it's also very important number related to convection heat transfer. Emerson property, it provides a measure of relative effectiveness of momentum and energy transfer in the velocity and thermal boundary respectively. Okay, the Prandtl number is a connection between thermal boundary layer and velocity boundary layer. Okay, because thermal boundary layer is a separate one, velocity boundary layer is separate one. Thermal boundary layer is related to energy concept, velocity boundary layer is related to mechanics or fluid mechanics concept. Okay, therefore the Prandtl number is only connecting medium between momentum or mechanical fluid mechanics concept and the thermal concept. Okay, this is another dimensionless numbers. Then second, the next number, and each number is having specific mathematical formulation which are available in the data book itself. Okay, so I cannot not explaining, or I am not giving the formula for that MS number. Only I can only now I am only explaining the concepts. Okay, not a formulas. You can refer the formulas in the thermodynamic HMT data books. Okay, then next dimensionless number is Grashof number. Grashof number. Grashof number. Okay, the Grashof number is ratio between buoyancy force to the viscous force. Okay, what GR is similar concept related to, or similar number is related to similar number like Reynolds number. Okay, but it is for the natural convection. The Reynolds number is for the forced convection. The Grashof number is purely for the Reynolds number is applicable for all flows, even either free or forced. But to flow, if a particular flow condition, Reynolds number is available. But Grashof number means is particularly for natural convection. Okay, because in natural convection, the heat transfer occurs in a natural manner. The phenomena for the natural convection I already explained in previous lectures. Therefore, due to the buoyancy effect, the heated or heated gases uh, uh, flow from the surface of the earth to the atmosphere in the vertical manner. Okay, therefore, anything flow in a vertical manner is the force is called buoyant force or buoyancy and flotation. This concept also available in the fluid mechanics itself. Okay, therefore buoyancy force means floating force. Okay, in natural convection concept, the heated gases are flow from the earth surface to the atmosphere. Okay, due to the buoyancy effect. Okay, then another one is viscous. The gases also having viscosity. Therefore, the viscosity reduces the flow. Therefore, the viscosity is an denominator, and the buoyancy force is a major driving force. Similar like inertia force in a Reynolds number. Therefore, and Grashof number is ratio between the buoyancy force by viscous force. Okay, this is another dimensional numbers related for the natural convection. Okay, or free convection, the main parameter is for flow condition. If the flow is laminar, either turbulent, classification is based on the Reynolds number. But in the case of natural convection, the classification is based on the Grashof number. Okay, the main important number is Grashof number instead of Reynolds number. Okay, but Reynolds number is also important in natural convection, but main parameter is Grashof number for the natural convection. Okay, then next number is Nusselt number. Nusselt number. Nusselt number is the main important number to find the heat transfer coefficient with the help of previously explained correlations. Okay, I already explained the difference between correlations and formulas. Correlations depends on the particular situations. With the help of correlations, we can find the Nusselt number. From the Nusselt number, we can determine the heat transfer coefficient. Okay, then the Nusselt number is ratio between the convection heat flux divided by conduction heat flux. Okay, okay. Then here like Prandtl number. In Prandtl number, the Prandtl number relates the thermal boundary layer and elastic boundary layer. Okay, like Nusselt number relates convection heat transfer and conduction heat transfer. Okay, because The heat is transferred from pipe pipe to atmosphere. The conduction and convection, both heat transfers are occurring. Okay, therefore how what is dominates, which is important. Okay, because every substance or the heat is transferred in all situations through conduction and convection. Okay, but what mode is dominant, which is the uh, which decide the what mode of conduction, either conduction, what mode of heat transfer occurring, either conduction or convection. Okay, therefore uh, then for that classification, the Nusselt number plays a major vital role. Okay, Nusselt number only relates the convection heat flux and conduction heat flux, or convection heat transfer or conduction heat transfer. Okay, for example, Nusselt number is equal to 1 means convection heat transfer is perfectly matches with conduction heat transfer. Okay, therefore there is no difference between convection heat transfer and conduction heat transfer. Okay, we can tell that heat transfer either conduction or convection, no problem. Okay, but Nusselt number is greater than 1 means the convection effect is dominant when compared to conduction. Okay, therefore for convection heat transfer, the Nusselt number is greater than unity. Once it reaches unity, then the heat transfer is changes from convection heat transfer to conduction heat transfer. Then the formulas are not applicable for that situation. You can use the formulas for the conduction heat transfer alone. Okay, therefore the Nusselt number is always greater than unity for convection heat transfer problems. Okay, this is the main important parameter for convection heat transfer coefficient and important concept for convection heat transfer coefficient. Okay, then next number, standard number. Standard. Next number, standard number. Ratio between heat flux to the fluid by heat transfer capacity of the fluid. Ratio between heat flux to the fluid and heat transfer capacity of the fluid. It's also another type of number, dimensionless number, but it has not as very important significance. It is for purely calculation. Okay, for the standard number is ratio between the heat flux to the fluid divided by heat transfer capacity of the fluid, which means how much amount of heat is applied to the fluid and what is the maximum absorbing heat for the fluid. Okay, for example, consider the water. Water, when it reaches the 100 degrees Celsius, it starts boiling, which means it changes its phase. Okay, beyond the sorry, it, it reaches the 100 degrees Celsius, it, the phase of the substance is liquid. Okay, for a particular situation, for our application, we need a liquid phase alone, not a gaseous phase. It's a limitation or restriction. Therefore, throughout the cycle or throughout the process, the substance maintain a single phase. For the situation, we know what is the maximum amount of heat that is given to the fluid and how much amount of heat we have supplied. These two data are very important because the beyond we supply the energy beyond the maximum limit, it changes its phase. Then the changes phase means the heat carrying capacity changes. For for our situation and for our restriction, we know that how much amount of heat is supplied, what is the amount of maximum uh, heat carrying by the fluid. These two data are very important. Okay, the standard number is played these two data. Okay, this heat flux to the plate by the transfer capacity of plate. Okay, next, Peclet number. Peclet. Peclet number. These names are the inventor names. Okay, at a scientific name, these names are the inventor names. Basalt or inventor, Grasshoff for one inventor, Stanton and Peclet, these are the inventors of these numbers. Okay, then Peclet number is the ratio between heat transfer by convection divided by heat transfer by. Okay, this also gives details for details for the relation between conduction and convection. Similar with Nusselt number. Okay, but there is no specific significance for the Peclet number. The Peclet number also having same significance related to the Nusselt number. Okay, then the last dimensionless number is Grad's number. The Grad's number. Grad's number means thermal capacity ratio between the thermal capacity of fluid per unit length by thermal conductivity. Thermal capacity means heat carrying capacity of fluid per length divided by thermal conductivity of the particular material. Okay. This is for the thermal capacity of the fluid per, which displays the fluid property and the material property, because the fluid flow over the plate or flow inside the plate, therefore the fluid is contacted with the surface, therefore what about the fluid property and what about the material property? Okay, these two properties are connected by the Gauss number. Okay, these are some dimensionless number related to convection concept. Okay, in future for various dimensional numbers are also available in the subject. Some more dimensional numbers are available in mass transfer and conduction heat transfer also. In future we can explain at the topic starts. Okay.